Welcome to the second part of our AVID page demonstration. In this second part, I will be demonstrating to you the advanced features of AVID page. As you recall, in the first part, we created a Predator UAV fuselage and a wing, and I showed you how easy it is to just put together these geometries. In the second part, I'll show you some of the more advanced features such as grouping, symmetry, and also the mass properties tool. So in this Predator UAV right now that we created in the first part, we can see that we're missing the tails. So let's start by just a recap. To be able to add a new component, it's just basically either double clicking on the component over here on the left or just dragging and dropping. So I'm going to just drag and drop a single wing, and a wing shows up over here. Now we'll use this wing component to create the diagonal tail for the Predator UAV, and all I have to do then is just have that wing selected, which it is, go to the shape parameters and change the parameters for that. In this case, the aspect ratio for the diagonal tail should be 4.45, add a taper ratio of 1, and an area of 22.5. Now that shows up over here. Then I can just rotate it about X to about negative 48 degrees. So let's do about 48 right there. I'm going to type it in, just make sure it's negative 48, and rotate it so that we can see it. The last thing we need to do is to move this wing over in its correct location. So X should be at about 27. And you can see it needs to be raised up just a little bit in the Z. So I'm going to raise Z to 2. And as we rotate, there you have it. Very quickly, we have got one of the diagonal tails. I'm going to rename that to diagonal tail, and we showed this in the first part of the demonstration, that we can rename components. Now instead of recreating the second diagonal tail over on the left side of the vehicle, I can just use the symmetry, and it's just easy as checking a box. And there you go. Just by checking the global XZ for that component, we just mirrored and had a symmetrical component mirrored over on the left side of this vehicle. The last thing we need to do here for the tails is to add a vertical tail. So again, I'm going to double click on this wing over here. We create a new component, change the shape parameters to an aspect ratio of 3, taper ratio of 0.88, and an area of 10. Now all we have to do is rotate it around about X to about negative 90 degrees. So you can see it's fairly easy just using the slider bars or just typing the number in and moving it to the correct location of about 27. So diagonal tail made, also the vertical tail. I'm going to rename that to vertical tail. Now we can, as I mentioned before, we can group components together, and that's easy enough. Just go to this group component and just drag and drop it in. And I'm going to rename this group to tails. To add components to a group is as easy as clicking on the component and dragging it to that group. And let me drag the vertical tail to the tails group. That shows up, and drag the diagonal tail to the tails group. So now once I've moved some of the components to the group, changing the group parameters would also affect all its children. For example, I'm going to select this tails group, and I'm going to rotate it around, and as I move the X location, the vertical and horizontal tail also moves together with it. So I can change parameters fairly quickly in the group that would affect all its children. Now what I would like to do now is to add a propeller, and in AVID page we have 2 propeller components. I'm going to use this propeller component called a BVE propeller because it gives us more control over its geometry. So again, drag, drop a propeller shows up. Let's look at some of the parameters that is available for propellers. That includes the number of blades. I can change the hub diameter, its diameter, its sweep angle, its cone angle, but also here there's a table, and I can upload or specify the propeller geometry based on its chord ratio as a function of radial station and twist, and also change its twist angle. I'm going to keep with the default right now, but just change the general parameters. In this case, the propeller is a two-bladed propeller. I'm going to change the diameter to 10. And let's just move the hub diameter to about 2. Now, as you can see, the propeller has a cone angle on it, which is set at 20. So let's just zero that out. And you have a propeller. Okay, so now all I need to do is just move it to the correct location at about 30. And there you go. Geometry of a Predator UAV, or at least a simple geometric rendition of a Predator UAV. I'm going to change the propeller to the name propeller, and there you have it. So very quickly, I can create these geometries. Now, the other advanced feature of AVID Page that is not in many of these geometry creators is the mask properties tool. And I'm going to just select the fuselage right now and demonstrate the mask properties tool. I'm going to click on this mask properties over here, and as you can see, the center of mass and moments of inertia has been calculated for the fuselage. And now this calculation is based on the geometry that you see here set as a solid. Now I can change that to a shell and specify a thickness, say 0.2. And immediately once I do that, the center of mass and the moments of inertia, as well as its other properties, are automatically calculated for you. And that's calculated based on the geometry that you see or that is rendered on the screen. Now, if I wanted a user-defined, if I had a weight and other mass properties in there, I can set the user-defined. I can type it in myself. Now, that's also good to be able to add internal components and check for packing and also check for balance. So I can add a new component. Say, for example, I can add a pod. So I'm going to just double-click on this pod. And a pod component shows up. We can't see it quite well, so I'm going to change it to transparent mode and then zoom in. So this is a pod right here that I can use to mimic an internal component, and I'm going to change its cross-section parameters so that we open it up so that you can see it a little better. So move that cross-section there. Now this pod could represent any internal component, say for example the payload. It could be, a fuel tank. So let's just change its length. Now I can move it within the aircraft, and I'm just going to rotate it around so that make sure it's inside. So I'm going to move the Z location. So if this part is inside, we can add internal components, and then I can change its mass properties to say a user-defined property, and I can change its weight to say 1 pound, and also change its center of mass and moments of inertia over here. And what that will do is that will put the mass properties of that pod. So now I can specify internal components. I can check for balance as I create my model. Now, if I wanted to see the mass properties of groups of components, I can do that also. I'm going to zoom out here. Say for example the tails. We had grouped the tails before, and the mass properties that's shown here for the tails is the correctly summed moments of inertia and center of mass of the vertical and diagonal tail. If I want the mass properties for the entire model, I can have that viewed by just selecting the vehicle mass properties. And in this dialog box, it gives you the I just docked that. Let me undock it. The weight of the vehicles as well as the center of mass and moments of inertia fairly quickly. Now I can also view the CG of this vehicle, and so there, let me render it as a solid, and as I move components around, that CG will change. So let me move the main wing, and you can see the CG of the main wing changes. The other feature that we provide here is being able to plot the weights of the individual components. So in this case, I have all my components over here and all this weights in a bar graph. I can obviously change some of the colors and properties of that bar graph. Say, for example, I want the main wing bar to be blue or green. So there it is. Now, and that's some of the cool features or the good features of AVID Page. I would like to just also add that once we're done or we're finished creating this geometry, we can export our geometries out to CAD using an IGES format. So I can save it as an IGES file or save its cross sections in terms of a Hermit format so that I can export over to Vortex Lattice. Now, all the components that are exported through IGES are described as NURB surfaces, so they are always smooth. So as you import them into CAD, they're not just points, but smooth surfaces in your CAD program. So that concludes our second part and our final part of this AVID Page demo. As I mentioned before in the first part, AVID Page is cross-platform compatible, so it runs on Linux, Mac OS X, and also Windows. So please contact us at www or at our webpage at www.avidaerospace.com for more information, and just click the contact us button if you would like to get in touch with us. Thank you for joining us for this page demo. I hope you enjoyed it.